The derating factor is found in Table 310.15b2 of the National Electrical Code apply when conductors are carrying current. In a multiwire circuit, only the ungrounded conductors, those actively carrying the load, are counted for derating purposes. In a scenario with 11 circuits, each using 2 current-carrying conductors, the total number of current-carrying conductors is 22. According to the NEC, the derating factor for 22 current-carrying conductors is 0.6. To calculate the adjusted ampacity of a number 10 conductor, we multiply its original ampacity by the derating factor. A number 10 conductor without derating is typically rated at 30 amps. After applying the 0.6 derating factor, the adjusted ampacity becomes 18 amps. Since 18 amps is less than the 20 amps required for the circuit, a larger conductor size is necessary. A number 8 conductor with a higher ampacity is chosen. Let's say a number 8 conductor has an ampacity of 55 amps. Applying the 0.6 derating factor, the adjusted ampacity is 33 amps. This exceeds the 20 amp requirement, making the number 8 conductor suitable. Conduit fill tables remain relevant in electrical installations because they prevent overcrowding of conductors within a conduit. These tables provide the maximum number of conductors of a specific size that can be safely installed in a particular conduit size. Overcrowding can lead to excessive heat buildup and insulation damage, potentially causing electrical failures or fires. To determine the correct conduit size, consult the appropriate conduit fill table. In the example with 16 number 8 conductors, a 1.25-inch conduit is required to accommodate them safely. The derating factors in Table 310.15b2 don't negate the importance of conduit fill tables. Instead, both derating and conduit fill tables work together to ensure electrical safety and code compliance. The derating factors address the reduction in conductor ampacity due to heat generated by multiple current-carrying conductors in close proximity. Conduit fill tables, on the other hand, address the physical space limitations within the conduit to prevent overheating and insulation damage. Ignoring either derating factors or conduit fill requirements can lead to unsafe installations. Overloaded conductors can overheat and cause fires, while overcrowded conduits can exacerbate heat buildup and damage conductor insulation. In summary, when designing and installing electrical circuits, firstly, determine the number of current-carrying conductors in the raceway. Secondly, apply the appropriate derating factors from Table 310.15b2 to adjust the conductor ampacity. Thirdly, select a conductor size with an adjusted ampacity that meets or exceeds the circuit requirement. Fourthly, consult the appropriate conduit fill table to determine the correct conduit size for the selected number and size of conductors. And fifthly, ensure that the installation complies with all applicable electrical codes and standards. Consider a scenario where you have 9 current-carrying conductors in a conduit. Based on Table 310.15b2, the derating factor would be 0.7. If you plan to use number 12 American wire gauge copper conductors, which have an ampacity of 30 amps at 90 degrees Celsius, you would need to apply the derating factor. Multiplying 30 amps by 0.7 gives you 21 amps. Therefore, the number 12 American wire gauge conductors, after derating, can safely carry 21 amps in this scenario. Now consider a situation with 20 current-carrying conductors. The derating factor from Table 310.15b2 is 0.5. If you intend to use number 10 American wire gauge copper conductors, which have an ampacity of 40 amps at 90 degrees Celsius, you must apply the derating factor. Multiplying 40 amps by 0.5 results in 20 amps. Thus, the number 10 American wire gauge conductors, after derating, can only safely carry 20 amps with 20 current-carrying conductors in the conduit. Suppose you have 4 current-carrying conductors in a conduit. According to Table 310.15b2, the derating factor is 0.8. You plan to use number 14 American wire gauge copper conductors, which have an ampacity of 25 amps at 90 degrees Celsius. Applying the derating factor, you multiply 25 amps by 0.8, resulting in 20 amps. This means that the number 14 American wire gauge conductors after derating can safely carry 20 amps in the setup. Now, let's say you have 30 current carrying conductors in a conduit. The derating factor from table 310.15b2 is 0.45. If you plan to use number 8 American wire gauge copper conductors, which have an ampacity of 55 amps at 90 degrees Celsius, you need to apply the derating factor. Multiplying 55 amps by 0.45 gives you 24.75 amps. Therefore, the number 8 American wire gauge conductors after derating can safely carry approximately 24.75 amps with 30 current carrying conductors in the conduit. Consider a scenario with 6 current carrying conductors in a conduit. The derating factor from table 310.15b2 is 0.8. If you plan to use number 12 American wire gauge copper conductors, which have an ampacity of 30 amps at 90 degrees Celsius, you must apply the derating factor. Multiplying 30 amps by 0.8 results in 24 amps. Therefore, the number 12 American wire gauge conductors after derating can safely carry 24 amps in this situation. Always consult the latest edition of the National Electrical Code and local electrical codes for specific requirements and regulations in electrical installations. Accurate interpretation and application of these codes are crucial for ensuring electrical safety and compliance. Electrical codes and standards are subject to revisions and updates, so it's essential to stay informed about any changes or amendments that may affect electrical installations. Proper training and certification in electrical work are necessary for individuals involved in designing, installing, and maintaining electrical systems. Qualified electricians and electrical engineers have the knowledge and expertise to ensure that electrical installations meet safety and code requirements. If you are not experienced or knowledgeable in electrical work, it's best to consult a qualified electrician or electrical engineer for assistance. Attempting electrical work without proper training and knowledge can be dangerous and may result in serious injury or property damage. Remember to always prioritize safety when working with electricity. Turn off power to the circuit before working on any electrical components, and use appropriate safety equipment such as insulated tools and gloves. Electrical work can be hazardous, and it's essential to take precautions to protect yourself and others from electrical shock and other hazards. Double-check all connections and wiring to ensure they are secure and properly insulated. Loose or poorly insulated connections can create electrical hazards and increase the risk of electrical fires. After completing any electrical work, test the circuit to ensure it's functioning correctly and safely. Use appropriate testing equipment, such as a multimeter, to verify voltage, current, and continuity. If you encounter any problems or unexpected results during testing, seek assistance from a qualified electrician. Regularly inspect electrical systems and components for signs of wear, damage, or deterioration. Replace any damaged or worn-out components promptly to prevent electrical hazards. Proper maintenance of electrical systems is essential for ensuring their safety and reliability. Keep electrical panels and equipment clean and free from dust, dirt, and debris. Accumulated dust and debris can cause overheating and reduce the efficiency of electrical equipment. Ensure that electrical panels are properly labeled to identify circuits and components. Clear labeling helps prevent accidental disconnection of the wrong circuit and facilitates troubleshooting and maintenance. Be aware of the potential hazards of working with electricity in wet or damp environments. Water can conduct electricity and increase the risk of electrical shock. Take extra precautions when working with electricity in wet conditions and use ground fault circuit interrupters, or GFCIs, to protect against electrical shock. When installing electrical wiring, use appropriate wiring methods and materials for the environment. For example, use weatherproof wiring and enclosures for outdoor installations. Proper wiring methods and materials help protect against moisture, corrosion, and other environmental factors that can damage electrical wiring. Consider energy efficiency when designing and installing electrical systems. Use energy-efficient lighting, appliances, and equipment to reduce energy consumption and lower utility bills. Energy-efficient electrical systems can also help reduce environmental impact by decreasing greenhouse gas emissions. Stay informed about advances in electrical technology and industry best practices. Continuous learning and professional development are essential for staying up to date with the latest electrical codes, standards, and technologies. Participate in training courses, seminars, and workshops to enhance your knowledge and skills in electrical work. Follow manufacturers' instructions and guidelines when installing and using electrical equipment and components. Improper installation or use of electrical equipment can void warranties and create safety hazards. Always read and understand the manufacturer's instructions before installing or using any electrical product. Be mindful of the potential for electromagnetic interference, or EMI, from electrical systems. EMI can disrupt the operation of electronic devices and equipment. Use shielded cables and enclosures to minimize EMI and ensure proper functioning of electronic devices. Consider the impact of electrical systems on building aesthetics and design. Conceal wiring and equipment whenever possible to maintain a clean and uncluttered appearance. Coordinate electrical installations with architectural and interior design plans to ensure harmonious integration of electrical systems into the building. Be aware of the potential for electrical fires and take precautions to prevent them. Install smoke detectors in all areas of the building and test them regularly. Keep flammable materials away from electrical equipment and wiring. Have a fire extinguisher readily available in case of an electrical fire. In the event of an electrical emergency, know how to shut off power to the building and call for help. Familiarize yourself with emergency procedures and contact information for local emergency services. Regularly inspect and maintain grounding systems to ensure their effectiveness. Grounding systems provide a path for fault current to flow safely to ground, reducing the risk of electrical shock. Check grounding connections for corrosion or damage, and replace any faulty components. Consider the use of surge protection devices, or SPDs, to protect electrical equipment from voltage surges. Voltage surges can damage or destroy sensitive electronic equipment. SPD divert excess voltage to ground, protecting equipment from damage. Install SPD at the service entrance and at individual equipment locations for maximum protection. Be aware of the potential for arc flash hazards when working with energized electrical equipment. Arc flash is a dangerous electrical explosion that can cause serious burns and injuries. Wear appropriate personal protective equipment, or PPE, when working with energized equipment, including arc-rated clothing, gloves, and face shields. Follow safe work practices and procedures to minimize the risk of arc flash incidents. When disposing of electrical waste, follow proper disposal methods to protect the environment. Recycle electronic waste and dispose of hazardous materials, such as batteries and fluorescent lamps, at designated collection sites. Avoid disposing of electrical waste in landfills or incinerators, as this can release harmful pollutants into the environment. Consider the use of renewable energy sources, such as solar and wind power, to reduce reliance on fossil fuels and lower carbon emissions. Renewable energy systems can provide clean and sustainable electricity for buildings and homes. Integrate renewable energy systems into electrical designs wherever feasible to promote environmental sustainability. Be aware of the potential for electrical hazards associated with overhead power lines. Maintain a safe distance from overhead power lines when working outdoors, and avoid contact with any objects that may come into contact with power lines. Overhead power lines can carry high voltages and pose a serious electrical shock hazard. When working near underground utilities, such as buried electrical cables, call before you dig to avoid damaging underground utilities. Contact a local one-call center to request that underground utilities be located and marked before starting any excavation work. Damaging underground utilities can result in service interruptions, property damage, and serious injuries. Consider the use of smart home technology to enhance energy efficiency, security, and convenience. Smart home devices, such as smart thermostats, Lighting controls and security systems can be controlled remotely using smartphones or tablets. Smart home technology can help reduce energy consumption, improve home security, and enhance overall quality of life. Be aware of the potential for electrical hazards associated with swimming pools, spas, and hot tubs. Install ground fault circuit interrupters, or GFCIs, to protect against electrical shock in these areas. Maintain proper bonding and grounding of metal components to prevent electrical hazards. Follow all applicable electrical codes and standards for swimming pool, spa, and hot tub installations. When designing electrical systems for healthcare facilities, such as hospitals and clinics, prioritize patient safety and reliability. Use isolated power systems, or IPS, to provide continuous power to critical equipment in the event of a power outage. Install redundant power sources and automatic transfer switches to ensure uninterrupted power supply. Follow all the applicable electrical codes and standards for healthcare facility installations. Be aware of the potential for electrical hazards associated with industrial environments such as factories and manufacturing plants. Use explosion-proof equipment in areas where flammable materials are present to prevent explosions. Maintain proper ventilation and grounding to minimize the risk of electrical hazards. Follow all applicable electrical codes and standards for industrial installations. When designing electrical systems for commercial buildings, such as office buildings and retail stores, consider the specific needs of the occupants. Provide adequate lighting, power, and communications infrastructure to support business operations. Use energy-efficient equipment and controls to minimize energy consumption. Follow all applicable electrical codes and standards for commercial building installations. Stay informed about changes in electrical codes and standards by attending industry conferences, reading trade publications, and participating in professional development activities. Continuous learning and professional development are essential for staying up to date with the latest electrical practices and technologies. Adhering to these practices, staying informed, and prioritizing safety are crucial for ensuring safe and compliant electrical installations. These principles contribute to the reliable and efficient operation of electrical systems while protecting people and property from potential hazards.